The 12 notes that we use in modern Western music are part of a system called equal temperament. This system is based on 12 equal semitones and octaves that are in tune. The origins of our musical system stretch all the way back to the ancient Greeks and the philosopher and mathematician Pythagoras. Around 550 BC, Pythagoras made a remarkable observation. Musical notes are governed by simple mathematical ratios. On the board time, if you get a string and pluck it, that'll have its own fundamental note based on its length and thickness. Divide the string in half and you get the higher octave. This is expressed using musical ratios. So we're looking at these, but what do these symbols actually mean? This is a 2-to-1 ratio. The first number is one note's vibration rate. The second number is the other note's vibration rate. So a 2-to-1 means the vibration has literally doubled. So how many times does this note vibrate per second exactly? Let's take the note A for example. A1 vibrates at 440 Hz and A2 vibrates at 880 Hz, exactly double. It's quite common for a player to know that A vibrates at 440 Hz because this is how we calibrate our tuners. If we half it again, I'm going to get another octave. He moved on. A 3-to-2 ratio creates a perfect fifth. In practical terms, the string is vibrating 1.5 times faster. These two intervals, the octave and the fifth, are the fundamental building blocks of music. This is why the fifth is known as the dominant, because after the fundamental, the 1, it's the next strongest note. Try this on your guitar. This principle applies to all stringed instruments. And extending that on, we also have the wind instruments, flute, saxophone, clarinet, etc. In every case, pitch is controlled by the length of the vibrating medium, including the pipe organ, which the ancient Greeks had all those years ago. They used different sizes of pipe to achieve the different notes. So fundamentally, all these instruments are doing the same thing. They're shaping vibration. With wind instruments, when all fingers are down, or in other words, all the holes are covered, the flute becomes a continuous tube of vibrating air. As you raise your fingers, the column of air becomes shorter and the pitch rises. Suppose a fundamental note vibrates at 100 Hz. The harmonic series naturally produces the first 1-to-1, fundamental, the second 2-to-1, an octave, a perfect fifth above the octave, 4-to-1, 2 octaves, 5-to-1, the major third, 6-to-1, the fifth, 7-to-1, slightly flat minor seventh, and 8-to-1, 3 octaves. A quick detour, I'd just like to introduce you to some advanced techniques on guitar and sax you may not be aware existed. What's called multiphonics on the saxophone, where a player can generate a chord based on the harmonic series.
That is brilliant.
Guitarists make additional harmonics by using modern specialized techniques. For example, on guitar what's called pinch harmonics, popularized by Eddie Van Halen. Fret like normal because the technique here is all in the strumming hand. Just after plucking, lightly tap your thumb on the string as it bounces back from the pick. So now this is the mega breakthrough. Pythagoras realized by stacking fifths, creating a cycle of fifths, you eventually generate all 12 notes. So now we have 12 notes. It wasn't all smooth sailing from there though, as there really was some tuning up in between. Tuning up for about 2,000 years. When you go all the way round the cycle, the final note does not perfectly match the starting note. This small discrepancy is called the Pythagorean comma, and because of this, some keys sounded beautiful and others sounded harsh and unstable. These unusable intervals became known as Wolf intervals. For centuries, musicians avoided certain keys entirely. By the 16th and 17th centuries, theorists introduced equal temperament. Instead of preserving pure ratios, they slightly adjusted every interval so that all keys become usable. This tempering spreads the tuning error evenly across all 12 notes, so that all keys are playable. Johann Sebastian Bach demonstrated this system with the Well-Tempered Clavier, a collection of 48 preludes and fugues written in every major and every minor key, proving that the system worked in practice. This laid the table for subsequent generations of great composers. This also explains why other musical traditions can sound unfamiliar to Western ears, such as Indian classical music and Arabic magam systems. These use different tuning systems, often closer to natural harmonic relationships rather than equal temperament. Back to the cycle of fifths, it's not just a diagram, it's a map of how music is constructed. Starting from C, each step is a perfect fifth.